Swayam Prabha. Digital India. Educated India.
Next, what we want to do is see what happens when IUV is not 0. Okay. When IUV is not 0, that is, I am dealing with the given axis y and z, what happens? If IYZ is not equal to 0, then whatever we did till here holds, this equation still holds, and still I will get y naught as this, z naught as this. Okay. And then whatever we did till there holds. So, when IYZ is not 0, I have u in general given by minus y minus y naught d square delta y d delta y by dx plus z minus z naught d delta z by dx Ex plus delta y function of x Ey plus delta z function of x Ez. The displacement field similar to u and v, I replace u and v with y and z here, remains the same. Then my sigma xx would be minus E times y minus y naught d square delta y by dx square plus z minus z naught times d square delta z by dx square this will be my stress. Okay. And then the condition that integral sigma xx dAx Ax has to be 0 would imply that y naught is given by integral E times y dAx. Here I have not assumed the beam is homogeneous, E dAx, and my z naught would be integral E times z dAx by integral E times dAx. Okay. These two you will get from this equation, and then you have the moment equation mz to be given by minus integral y minus y naught sigma xx dAx from our definition in the very first class when we began the beam bending problem. This will be the definition of mz, and you add a definition of my as integral z minus z naught sigma xx dAx, right, Ax. Okay. Now, this will tell us that mz is given by E times I zz d square delta y by dx square plus E times I yz d square delta z by dx square, and my would be given by E times Iyz d square delta y by dx square plus E times I d square delta z by dx square. This assumes beam is homogeneous, that is, it is made of the same material, there is no difference in tension and compression, or there is no difference of materials in tension and compression. Okay. Now, what I have to do is I have to solve these two equations, to get delta y by dx square d square delta z by dx square in terms of my and mz. Okay. So, there will be a negative sign in here. Okay. So, now to solve this equation I cast it in this following form: mz my is equal to E times Izz Iyz minus Iyz, okay, Iyy into d square delta y by dx square d square delta z by dx square. Okay. Now, I invert this 2 by 2 matrix. From here I get d square delta y by dx square d square delta z by dx square into E is 1 by Iyz squared minus Izz Iyy, okay, into minus Iyy minus Iyz Iyz to Izz into mz my. Okay. Now, from here I get that d square delta y by dx square into E is Iyy into mz plus Iyz into my divided by Izz into Iyy minus Iyz squared, and E times d square delta z by dx square would be minus Iyz into mz plus Izz into my divided by Iyy Izz minus Iyz squared. Okay. So, we have found these two. Now, going back to the expression for the stress, I will get it as sigma xx would be, going back to the expression for the stress, it will be minus y naught into Iyy to mz plus Iyz into my divided by Iyy Izz minus Iyz squared plus z minus z naught into Iyz mz plus Izz my divided by Iyy Izz minus Iyz squared. Here the negative sign comes because it is minus y naught into E times d square delta y by dx square. So, that negative sign comes here. Here it is minus E times z minus z naught into d square delta y by delta z square, and hence this negative sign does not propagate into here. Okay. Okay. So, that is the expression for stress. Now, let us look at special cases. Let us look at the case where Iyz is 0. Special case where Iyz is 0, then your expression for sigma xx becomes minus y naught mz by Izz plus z minus z naught into my by Iyy. Okay. This is the same expression that we got in here. It is same expression that we got in here for sigma xx, except that u and v roles are changed to y and z now, except that u and v roles are changed to y and v now. Okay. U is y, v is z. Okay. So, this mz by Izz as a negative sign, you can see that mz by Izz as a negative sign in here. Okay, so this is same as what we got there. So it is consistent now. Okay. The second social case that we are going to consider is when there is moment only along one direction. Case 2, I y z is not equal to 0, but m y is 0. I applied force along only one direction, but I did not apply it about the principal direction. Okay. Now sigma x x would be minus y naught, m y is 0. So, I have I y y divided by I y y I z z minus I y z squared into m z plus z minus z naught into I y z into m z divided by I y y I z z minus I y z squared. Okay. Okay. So, now this is where you have only one moment m z moment, but the stress varies both along y and z direction. Okay.